Hey everyone, welcome to learn the algorithm with me together. Today let's take a look at the 169 majority element. We'll be given array numbers of size n and then return the majority element. What does that mean? Like, what is the majority element? So the majority element means that element will be appears more than n divided by 2 times. In other words, it means that at least half of these numbers are the majority element. Let's take a look at these examples. Like we have three numbers, 3, 2, 3, and then the number 3 occurs 2 times and 2 only occurs 1 time. So the total number is 3 and half of it is 1.5. And now the number 3 occurs 2 times. Obviously, it is greater than 1.5, so the output will be 3. The majority number is 3. Or we can take a look at this one. Like we have these numbers, right? And also, first thing, we can do a simple count. Like, for example, we have map and we have key value, and the key is the number and the value is the count, right? And now we have number, like for example, it's 2. How many 2 here? 1, 2, 3, 4. So we have 4 2, and also we have number like 1, we have 3. So the total number here is 7, and half of it is 3.5, and the majority number is 2 because there are 4 2, so 4 is greater than the 3.5. That's why the number 2 is the majority number. So for this solution, we can first like loop the numbers, and while we looping numbers, we build the counting map, right? And after we build the counting map, we also know the total numbers. And then we can like go through the map and check which value, I mean the counting value, if the counting value is greater than the total numbers, half of the total numbers, then we just return the key, right? So I think this is the most straightforward approach we can think about. And the time complexity will be, we have 2 loops. Of course, the first loop is looped all the numbers. It will cost us like on time. And for the second loop, it will be less of the numbers because some numbers are just like we are put them together. So at least the first time is we have to loop like 7 numbers, but the second time is because the second time is only 2 numbers. It's just how many numbers we have. So total the time complexity will be on because we get the maximum looping time. And for the let's say time complexity will be on, and the space is because we use a map, we also cost like the on, and m here means the number, the quantity of different number, right? And here the n means the total count of number. So like the total count of number is 7 here, and the quantity of different number is just 2. And of course, just simply say the space is OM, but actually it's not. Yeah. And then we are thinking that, is there any way to improve it? Like we don't need extra map, or at first, at least we can think about we are not using the hash map. We can use an integer array, so that will save us some complexity, space complexity, like improvement 1. Use array instead of hash map, because the key value is just the numbers, and we can use the index instead of the real numbers. It can also help us to like build a counting map. Or probably we don't need this counting map. How we can do that? Improvement 2 as follow. So now let's say we still have these numbers. I'm thinking that because like the majority numbers, the majority elements must be like greater than half of the total numbers. So it means that if we are assume that the current number is the majority numbers, and then if we are not, we can start to counting the majority numbers. And once we meet another number not equals to the assumed the majority numbers, we can just like minus 1. It means that, in other words, we can like take this for example. Like we still have this as an example, and now let's see, if we assume the 2 is the majority number, we can say candidates majority number, right? We say it's 2, and we start to count it. Like we have 1, and next is still 2. We add it to 2, and now the first time we saw it is not the majority number, which we assumed as not the real one. We can just decrease it, the counting, to 1, and then we meet another 1, becomes 0, and then move to another 1. And now since the count is already 0, it means that we can probably reset it. Like you can see it here, we can reset it. We can now reset the majority number. We assume it is 1, right? The next one we saw. And then when we are seeing another number which is not equals to the assuming number, we can make the count decrease, right? Let's go back. Like when we assume the 1 as another candidate, we make the count as 1 again, and move to next is 2. Now it decreases to goes back to 0. So this 1 and 2, they can be paired. And now let's move to another. We assume another one is a candidate again. So the candidate go back to 2, and now we can count as 1. So after we go to the end of it, if the candidate is still like the counting number is greater than 0, it means that this is the real majority numbers. The idea is just like pairing each majority element candidates with the not majority elements, and that's kind of technique like pair cancellation. So after repairing it, the last one definitely will be left is the majority number. So this is the second method I'm thinking about, like the pseudocodes we can write is we can assume the first candidate majority number as the first numbers, right? And then we can as a count like 1, and then we'll start to loop from the second place. Loop the numbers. So if the current number not equals to our candidate number, the count will -1, but if it equals, the counts will be increased. And now before we are adding 1 or decrease, we can also check if the count equals to 0. So if already equals to 0, we can reset the candidates. Right. Okay, so at first we don't have to set the first one, because we can just make the count as 0. So the count is 0. The first number will always be the candidates. And then after redoing all the loopings, we can just return the candidate we have. So any corner case I'm thinking about, so at least the length of the numbers will always greater than 1, and if it is a negative or positive number, does it matter? I believe it's not, because we are more caring about the counts, not about the numbers. Right. So for this solution, I believe the time complexity will be, we just look for ones with still like on, and the space already constants, because we don't have any extra data structure to help us to store any value, only the variable. But initialize a variable, it doesn't cost us a lot of space. We can just assume it as like constant time. And now let's move to the coding part. Right, and now first we have to initialize our candidate number as the first one, and we can have the count, like the variable counter, to help us to count. Like at first it will be 0, and we start to looping all the numbers in the array. And if the count equals to 0, we reset the candidate number as the current one. And also, if the current numbers equals to candidate numbers, we can just add one more count. Else, if not equals, just -1. and then we return the candidate's number. Let's run it. Cool. So any other corner case, like if we put some like negative numbers here, right? We still pass the cases. And this is like 1, 2, 3, 4, 5, 6, 7. And how about like we have like even number. I have one more. Of course there's no majority number. 1, 2, 3, 4. Alright, so it means that the total numbers must be like the odd. How about 2? Let me check. Okay. Yeah, so if there are like 2, 4, and the rest 4 is other numbers, we don't have the majority numbers. It means that the majority number must be, the number of the majority number must greater than 4. We will have like 5 or say 7, but we cannot just have 4. Okay, and let's submit it. Cool, so all the test case pass. And from this problem, we can learn that we can use a counting map array as a solution, but if we want to save some space, probably we can use a variable to help us to keep track of the things. And this is also kind of a technique like pairing cancellation. Like if we are pairing some counts, so the rest of it must be the result. And if you think this, I think this is what we can learn. And if you think this video is helpful, thanks for giving me a thumbs up, and I really appreciate your encouragement, and thanks for watching.